In this video, we are going to cover some common network-based attacks. And this is our networking and routing infrastructure here. We've got the internet, we've got some ISPs, and we've got some BGP routing, and we've got some switches, and we've got some VLANs, and we've got some VMware machines and hypervisors. And this is the corporate environment, right? It's a beast of a network. There's a lot of things that are going on. And I'd love to cover and spend some time here in this video to cover four basic and four common network-based attacks, starting off with our very first sandbox escaping. Now, sandbox escaping, if you're unfamiliar with what a sandbox is, think of sandbox as a safe environment. So typically, as we have our corporate infrastructure, we may have a test environment and UAT environment where we'll go away and test certain functions, features across our development environment and our corporate environment, and then they'll make their way into our production, I'll say prod, and things like that where the infrastructure will kind of go through stages before it gets deployed into our corporate and production environment. So think of a sandbox environment where it's a safe environment where we can go in and basically, if there's a little bit of malware that we may have found or a machine gets infected, we can take that machine into this isolated component of it's maybe a system or a sheepdog system where we've got an actual platform that allows us to test and detonate certain assets. So if these are all PCs here, we can all connect them up to that safe environment, and then we can let loose of that malware, for example, if it's on a specific host, and then we can see what it kind of does. So this environment is typically isolated from, corporate network and infrastructure environment. So we don't want this on our production environment, of course. So typically what would happen with a sandbox escape is if an attacker has found himself or herself into this environment, they basically tend to crash, or they'll want to get out of this environment and they'll cause some sort of disruption to that sandbox environment if they're in there. Now, typically you want to destroy it so that way the customer or the company itself doesn't have a way into then test and validate this control. So typically they'll go away and they'll perform some sort of service inoperability to take down that sandbox environment. So think of this as a safe haven for running our applications via our operating systems or through browsers, and then we can basically run and test our systems in, right? So it's a safe environment that we can test and make sure that there's the hosts and the infrastructure are all safe from harm. So typically as an attacker, you want to sort of not have anyone have that option to go away then and perform any sort of remediation activities. So typically with a sandbox escape, we want to destroy that environment, and then we want to continue on with our attacks. So some sort of prevention mechanisms is to make sure that everything is up to date, right? And if we've got if we've got a certain infrastructure that we're running, make sure that environment is patched through the virtual machines, the browsers, the application state. That way there's no disruptions or any possible attempts to escape that sandbox environment. So that's our very first one. So sandbox escape is highly common, just for you to be aware of. The other one that we've got here is our virtual machine hopping. And our VM hopping is basically taking a hypervisor. So a hypervisor and has multiple guests in there. And then all these guests over here kind of use up obviously all the resources of that server. And basically that virtual machine is a way to sort of manage and obviously group together those guests and manage the resources of the servers and infrastructure and stuff like that. So VMware hopping is typically, as an attacker gains access to another VM running on that same hypervisor. So if we've got maybe a machine here that's infected, the attacker will then try and hop into another virtual machine state. So very common. Think of this in terms of a hosted and in a hosted virtual environment. So if you think some sort of cloud provider, think of that as in the provider provides that isolation between the different clients and the host and the VMs. So there's isolation between them, just like a firewall will do, right? You provision rule sets and you provision the filtering to happen, and then we allow what access those resources tend to have, right? So think of VMware hopping as that sort of approach where you're trying to gain access to other VMs in that environment, either through the hypervisor itself. So some common prevention mechanisms here are Make sure that there's isolation done correctly, either through VLANs or we've got private VLANs that are properly segmented out. So separating the network traffic and obviously ensuring the hypervisors themselves are all up to date. So making sure that patch management cycle and vulnerability management is also taking place, and the actual hosts themselves are obviously up to date and are current. Then we've got VM escapes. So typically similar to like our Sandbox escape, with our virtual machine escape, basically here the attacker tries to escape a specific VM. So any machine that they're potentially on or the hypervisor, then they want to gain access to any potential, being that King Kong of the environment. So similar to virtual machine hopping, where we may be hopping between different virtual machines, VM virtual machine escaping is us getting access to the actual mothership in terms of the actual hypervisor itself. So how do we go away and prevent that? Well, making sure that patching our hypervisor, ensuring that's up to date and current, is going to obviously perform any sort of mitigation and prevention against the hypervisor being taken over or being attacked. Finally, as we sort of wrap up this short course, I've got another part 2 over here that I'm going to cover in just a moment. So I'm going to split this video up into 2 parts. So we're going to cover 4 and then 4 again. The last part here is BGP hijacking. So I just had a bit of a BGP hijacking. And if you're unfamiliar with what BGP is, think of BGP as the routing protocol for the internet, right? I'm not going to go into the whole metrics and the weighing and how that all kind of works, but think of BGP as a bloated protocol, similar to OSPF if we're routing between 2 different routers. So if I've got a router down here and this is running OSPF, if you're familiar with routing, if you're not, that's okay. I'm not going to cover the basics of OSPF and EIGRP and things like that, but think of this as in OSPF likes to know about everything in the network. So the kind of way it works is it will perform adjacencies and it will basically advertise its networks with every other network. So it kind of has this little roadmap of how to get to, pretty much everything and anywhere, right? And then obviously the best routes become part of the routing table and things like that. So I'm not going to go into the basics of, and obviously the core foundations of OSPF and routing. This is not what this is intended to do. However, BGP is kind of like OSPF, but for the internet, right? It's a slow protocol, it's a bloated protocol, and it's the backbone of the internet. So anytime we transmit routes across the internet, BGP is that thing that's doing that for us. So packets find their way across the internet. So as BGP then begins to advertise its routes to those other routers, they advertise their routes to each other, kind of like OSPF. If we look at EIGRP, it's more of a distant vector, so it only knows things its neighbor tells it, not everything else, and then it kind of formulates its own, diffuse or update algorithm. If we're talking about EIGRP being Cisco proprietary, and it goes away and sort of does its own thing. BGP is a little bit different. So as we sort of begin to perform maybe BGP hijacking attacks, which I haven't really seen a real BGP hijacking attack, but they do exist. Typically attackers here begin and send out basically, will spin up another router of some sort and then begin advertising that same route in multiple areas. So if I look at this, little network over here and think of these as BGP routers, if I go away and then spin up another router over here, and then that router has a better metric. Now, BGP has, 5 or 6 different metrics. It goes away and calculates the weight, and all these other different sort of features, and then it calculates the best metrics. So if I go away then and advertise my own route, which in hindsight has a better route, or it'll basically be a conflicting route, right? So if I go away and configure a better route on this, router here to sort of begin that BGP hijacking process, then it's going to conflict as it sort of advertises its route over to this guy. It's going to say, well, I've got a conflicting route with this host or this, subnet range or whatever that's going to be. And typically what we will do here is, well, then we could advertise a more detailed route. So it would be our more preferred route, so than the original route. And then the traffic would obviously come through us. And then we become that sort of, man in the middle essentially. And then we can start hijacking those routes. So some prevention mechanisms when we're talking about BGP hijacking, so I'm just going to say preventions. Well, the first one is head over to MANS. And MANS is it's not really a standard or anything like that. It's more of a community, and it basically stands for the mutually agreed norms for routing security. It's basically an initiative to reduce routing threats. So they're doing some really cool things. You can head over there to community. They've got resources and functions to support and help, basically reducing these routing attacks and threats. Then the other thing that we can do is filtering. Now, if we are doing proper filtering, we can obviously making sure that our routing filters are there to prevent these false routes taking place. So if anyone sort of comes in and plugs in a router to then begin this BGP hijacking process and starts advertising those routes, well, we want to make sure that the receiving end, that routers that's receiving that, is properly filtering those routes to prevent those false routes from coming in at all. So, you can set up your peers correctly in a way where it will only hear what that peer has to say rather than trying to receive everything else from maybe an unknown peer. Source address prevention. So think of this as, I'm going to say source address validation. And this is similar to like our IP source guard, where we're preventing those spoof packets. So we can go away and enable that on the router and then specify its actual hosts. And then again, it'll look at the validity of that source address and validate the source address traffic that it's coming from a legitimate host. And then finally, a very common or uncommon way, depending on how you look at this, is publishing your information, right? And you can publish your your contact information. Let me just clean that up a little bit. We've got contact info. That way, if we have updated our contact information, if people have any problems or challenges with, I guess, the validity of those routes, well, then they can be in contact and say, hey, we're noticing XYZ. Do you know about this? And then you can go away and investigate. So they're the 4 sort of common network-based attacks. In the next video, we're going to cover 4 more. I hope you've enjoyed this video. And as always, I will see you in the next video.